Welcome to the Tech Mechanics. Before we begin today's topic, there's one important thing I'd like to mention. If you've been following this playlist from the beginning, you'll notice that we are not just learning individual concepts, we are building a complete solution architecture, step by step. In our previous videos, we've already learned how architects think, how business requirements become an architecture, and we've designed a complete shopping app architecture from scratch. Along the way, we've also explored important concepts like SQL versus NoSQL, Redis, Elasticsearch, Kafka, RabbitMQ, API Gateway, Load Balancer, CDN, WAF, Authentication, OAuth 2.0, and even the difference between monolithic and microservices architecture. Today's topic builds directly on those concepts. If you are new to this playlist, I highly recommend watching the previous videos first because each video connects with the next one. By the end of this series, you'll have a complete understanding of how real-world enterprise applications are designed by solution architects. Now, let's continue our journey and understand how microservices actually communicate with each other. In our last video, we learned how architects split a large application into multiple microservices. But here's the next challenge. If user service, order service, payment service, and inventory service are all separate applications, how do they communicate with each other? Should they call each other directly? Should they use REST APIs? Should they use message queues? Or should they use gRPC? Today we'll answer these questions using our shopping app architecture. In a monolithic application, modules communicate through simple function calls because everything runs inside the same application. But in a microservices architecture, every service runs independently. That means services must communicate over the network. This introduces latency, failures, retries, and security considerations that architects must carefully design for. REST APIs are the most widely used communication method between microservices. One service sends an HTTP request, and another service immediately returns a response. REST is simple, easy to understand, and supported by almost every programming language. That's why architects often choose REST for synchronous operations where an immediate response is required. Imagine a customer clicks place order. The order service immediately calls the payment service using a REST API. The payment service processes the payment and returns either success or failure. Since the customer is waiting on the checkout page, an immediate response is essential. REST works perfectly in this scenario. Sometimes speed becomes critical. Instead of sending JSON over HTTP, architects use gRPC. It transfers compact binary data, making communication much faster and more efficient. It's especially useful for internal communication between backend services where performance matters more than human readability. Not every task requires an immediate response. After an order is placed, sending an email confirmation doesn't need to happen instantly. Instead of making the customer wait, the order service places a message into a queue. The notification service processes it independently. This creates a faster and more resilient application. Let's use our shopping app. The order service calls the payment service using REST because the customer needs an immediate result. The order service may use gRPC to communicate quickly with the inventory service inside the data center. Finally, it publishes an event to a queue so the notification service can send emails or SMS messages without delaying the customer. Architects don't ask which technology is best. They ask what the business requires. If users need an immediate response, REST is a good choice. If backend services exchange large amounts of data quickly, gRPC is often preferred. If work can happen later without affecting the user experience, a message queue is usually the best solution. Modern enterprises rarely rely on a single communication style. Amazon, Netflix, Uber, and Spotify use REST APIs, gRPC, and message queues together. They choose the right communication method based on the specific business requirement. This flexibility is one of the biggest strengths of microservices architecture. Let's summarize. REST is ideal when an immediate response is required. gRPC provides fast, efficient communication between internal services. Message queues enable asynchronous processing and improve reliability. Great architects don't choose one technology for everything, they choose the right communication method for each business scenario. In our next video, we'll explore event-driven architecture in depth and see how companies like Amazon and Netflix build highly scalable systems using events. If you enjoyed this, smash that like button and subscribe to The Tech Mechanics.